to notes. Solving equations using the distributive property. Alright, so yesterday we actually talked about combining like terms, okay, in the context of solving equations. Today we're going to be using the distributive property. Now, I actually have an acronym written here that I find very helpful. It is, don't call me a monster. Don't call me a monster. Okay, and I actually wrote a song about it, and some students really liked it. So, don't call me a monster. First step here is distribute. Today we're going to be doing that. Distribute, combine like terms. We're not going to touch this one yet. It's going to be move variables. Okay, we're not going to do that though. Add, subtract, multiply, divide. Okay, those are the steps we're going to apply to these problems. Okay. Solve the following equations using the distributive property. On number 1, our first step is going to be to distribute. To take this 3, multiply by everything inside the parentheses, and so we get 3x minus 6 equals 18. Now, at this point, it ought to look very familiar, because our next step is going to be, well, we can't combine like terms, but we can add. We are going to add 6. This is kind of like in the last unit. So we're going to add 6 to both sides, okay, which gives us 3x equals, that should be 24, and then dividing by 3, should get x equals 8. Now, just like in the past, we need to check our answer. Okay, we need to plug this back in. So, back in that original equation, 3 times x minus 2 equals 18. So if I plug this guy in, 8, where x was, that's going to be 6. 3 times 6 is, in fact, 18, and this checks out. All right. Next, same steps. We will distribute first our 5. So that's going to be 5h. And a really common mistake is not to distribute the number on the outside, the coefficient, to everything. Okay, so make sure you do that. And I'm doing this one step at a time. That's minus 20 equals 10. All right, now we need to add 20. All right, so we have 5h equals 30. Okay, dividing by 5 there, we get h equals 6. And again, before I really want to call that good, let's plug that in. 5 times h minus 4. H minus 4 equals 10. So if I plug in 6 where h was, that's 2. 6 minus 4 is 2, times 5 gives us 10. This checks out, and our answer is, in fact, h equals 6. Okay, number 3. We need to be a little careful about this one, because we have 9 equals negative, parentheses, x plus 2. This negative sign out here, okay, we make sure when we distribute this, we do it properly. Now I'm going to write that understood 1 right there. So negative 1 times x is negative 1x. Negative 1 times a positive 2 is minus 2. And now my whole equation is in blue, but now I have an equation I can solve. So we are going to need to add 2 to both sides. Add 2. So we get 11 equals negative 1 times x. Dividing by negative 1, we get x equals negative 11. Plugging that back in, okay, 9 equals negative, or the opposite of x plus 2. So that's negative 11. So if I add these together, that is negative 9. So that'd be negative 9, which is positive 9. And so our answer is, in fact, x equals negative 11. Now, just like in the last unit, there is no reason to ever get anything wrong on these, because you can always get to the end and check it. That's one thing I like about equations. You can always plug your answer in and check it. All right, let's move on to number 4. First thing we need to do, just like we did in the past, distribute that negative 2. So we will have negative 2y plus 12 equals 44. Okay, this time we're going to have to subtract 12, which should give us 32. Bringing that down to negative 2y. And then dividing by negative 2, we get y equals negative 16. And again, Negative 2 times something minus 6 equals 44. If I plug that in there, keep writing the wrong numbers. If I write that in there, negative 22, and it is positive 22, so it does check out. Okay. Number 5, distribute the 4 in this case, since our variable and all its expressions on this side. Okay, 2 equals 4x minus 28. Adding 28 to both sides. Remember, we have to do the opposite operation, the inverse operation. To cancel this out, we need to make a 0 pair. That's the goal. So 30 equals 4x. Okay, dividing by 4. X equals, and that should simplify to be 15 over 2, or 7.5. Alright, so let's see if we can plug this in, just like we did in the past. 4 times 15 over 2 minus 7. Now, I know for a fact this is going to end up being 1/2, because this is 7.5, and 1/2 of 4 is 2, so this does check out. That's my goal of checking that. Okay, number 6, distribute the negative 1/5. Okay, that's going to be 1/5 times 5 is 1, so that's negative 1x. That's going to be plus 2 equals 0. Subtracting 2 from both sides. Negative 1x equals negative 2. And then dividing by negative 1, we should get positive 2. Right, x equals positive 2. So plugging that in up here, negative 1/5, 5x, so 5 times x minus 10 equals 0. We plug 2 in there. Well, that's 10 minus 10, that's 0. 0 times anything is 0. It does check out. Now, you can use your calculator. I'm doing most of this in my head and just kind of checking it real quick. You can use the calculator. In fact, please do. Use the tools that you're given. All right, number 7. Distributing again. In fact, on all these, we're going to have to distribute. So 4 times 3p is 12p. 4 times 10 is 40, so plus 40 equals 18. All right, and let's see, subtracting 40 from both sides. All right, so that should give us a negative 22. Yeah, 22. Okay. So that gives us 12p. Dividing by 12. P equals negative 11 over 6. Okay, now that one's a little trickier to check, but if you're using our calculator, it's not that big of a deal. 3 times negative 11 over 6 plus 10. Hopefully that is 18. So that is going to be negative 11 over 2. Okay, so it's 4.5. 4.5 times 4 is 18. Yes, it is. Checks out. Strange number. Okay, we have this fraction that actually is going to be a decimal. As a decimal, it's repeating. Okay, but it still, if you plug it in, you should get a true statement. That's the goal of having a solution. Number 8. I haven't seen one like this before. Actually, we did in the last unit, or maybe it was the first unit. We're going to take our 3 and distribute it going to the left. Okay, or from the right. So we get 3 times a, which is 3a, minus 15 equals 0. Okay, adding 15 to both sides. Okay, we have 3a equals 15. Dividing by 3 on both sides, a equals 5. Okay, now before I call it good, I want to check that. So we get 5 minus 5 times 3 equals 0. 0 times 3, yes, it checks out. Because that's 0, anything times 0 is 0. So that is a true statement. Okay, number 9, distributing 2/3 to both sides. See, that is actually going to be 2x. The 3's cancel out. Multiplying there, we get plus 4 equals 4. Yes? Okay. Now subtracting 4 from both sides, we get 2x equals 0. Right, dividing by 2, well, 0 divided by anything is just 0. So x equals 0 is our solution, provided it actually checks out. Plug in 0 there, 2/3 times 3 times 0 plus 6 equals 4. That is 0, so that's 6. Okay, yep, 4. Checks out. So as a good side note here, x equals 0, 0 is a valid solution. It's a really common valid solution, actually. So just because you get a 0 at the end doesn't mean anything strange. We're going to have something a little bit strange here in a little bit. No solution, all real numbers, things like that are going to happen within the next few days, maybe even today. But x equals 0 does not mean there's anything wrong with it. Okay? 0 is a number. That's all we're looking for, right? It's just a number. Okay. Number 10. Starting here, we get some words. Write an algebraic equation from the verbal description and then solve. All right. So twice the sum of 5 and a number is 18. What is the number? The first thing I'm going to look at is the word is. Is always translates to equals. So equals 18. Now, we have right here twice something. Well, twice means 2 times something, right? Okay, so twice the sum of 5 and a number. We don't know what our number is, but I'm going to go ahead and use n. Okay, so the sum of 5 and n. So there's our equation. That is over half the battle. If you can get the equation down, then you are on your way there. All right, so distributing the 2, we get 10 plus 2n equals 18. I guess I need to draw that in. 2 times 5, 2 times n. Subtracting 10, because we want our variable by itself, we get 2n equals 8. And dividing by 2, n equals 4. Alright, now if I plug 4 back in, up here, then that would be 9 times 2, which is 18. Okay, it does check out, but you always want to check that once you get down to the very end. Number 11. 3 times the sum of 7 more than twice a number is worded very poorly. 3 times the sum, how about this? 3 times 7 more than twice a number. Okay, so scratch the sum of out there. So 3 times something is 27. And it's going to be this part right here. 7 more than twice a number. So more than means adding, so add 7. And then twice our number, that's going to be 2n. I'm going to go with n still. All right, distributing this, we get 6n plus 21 equals 27. Subtracting 21 from both sides, we get 6 over here, so 6, and that's 6n. And then dividing by 6 on both sides, we get the n equals 1. Alright, now let me grab a different color and see if I can point this out. If we have n equals 1, if that is 1, that's 2 times 1, which is 2, plus 7, which is 9, times 3, which is 27. Yeah, I forgot what number I said. That's 9 times 3 is 27, yes. So this checks out. So n is in fact 1. Alright, 12. Half of the difference of 8 and a number is 16. What is the number? Okay, if I don't know anything else, is 16. I know it's going to be half of something, so I'm going to go ahead and do this. Half of something. And it says the difference. Difference is subtraction. So the difference of 8 and a number. So 8 minus, you know what, I'm just going to be adventurous. Let's go with t. And yes, I'm putting a little tail on that so that it looks like it's a t versus being a plus sign or something like that. Alright, so let's distribute 1/2 times 8, which is 4, minus 1/2 times t is minus 1/2 t, equals, we'll bring our 16 down. Notice that 1/2 does not affect that 16 at all. It only affects what's right next to this parentheses that it's just right up next to. Okay, so here we want to get, I need to do something a little different here. We want to get the t by itself, right? Well, I can't just get t by itself because these two guys are actually attached. So I really need to get rid of this guy. Well, he's plus 4, so I'm going to subtract 4 from both sides. So that cancels out. I get negative 1/2 t equals 12. All right, now at this point, I need to get rid of this negative 1/2 t. These are multiplied. So you really have two choices. You can divide by negative 1/2. Okay, so let me write this twice here, and I can point out what I'm going to say. 1/2 t equals 12. You can either divide by negative 1/2. Be careful if you type that in your calculator. Okay, or you can multiply by negative 2/1, the reciprocal. I don't think I like that color too much. Okay. Alright, so if you do either one of those, so here you get negative 24. Over here, you get negative 24/1, which is just negative 24. So either way, you get the same answer. So it doesn't matter which way you do that. Now, I will go back and plug this in, though. 1/2 of 8 minus negative 24, because that was our solution, equals 16. This is positive 32. Half of 32 is actually 16, so it does check out. All right, number 13, write an equation for the perimeter of the square and then solve for x. Okay, so first, how do we find perimeter? Well, anything. It's adding up all the sides, right? So if we knew what all the sides were, well, it's a square. They're all the same. So we can say, okay, there's 2x plus 3, 2x plus 3, 2x plus 3. And you could do that. That's actually kind of like what we did yesterday. However, we know that all sides are the same, so 4 times 2x plus 3 will give us the same answer as adding up all the sides. The only problem here is we know, it's not really a problem, it's a good thing, we know what the perimeter is. So instead of p right there, we know that it's 100. So this is the equation we're really supposed to solve. All right, so 100 equals, if we distribute 4 right there, 4 times 2x is 8x. 4 times 3 is 12, so plus 12. Subtracting 12 from both sides, it's going to be 88. You might not want to go 88 miles an hour unless you're in Back to the Future, in a nuclear-powered car. All right, dividing by 8, and x equals 11. Now let's check that actually in this problem over here. If x is 11, sorry that's not perfectly square, assume it is. If you plug 11 in for x, then that means this side right here is 22, 25. If you have 4 25s, what's the perimeter? It's 100. So, in fact, x equals 11 does check out. All right, last question we have on these notes, number 14. Review. If a regular pentagon side length is 2x minus 1. Regular meaning all sides are the same. There's Pentagon. If all the sides are 2x minus 1, write an expression to represent the perimeter of the Pentagon. Okay, so find the perimeter of this guy. Well, if it's regular and it has 5 sides, then that means our perimeter is 5 times 2x minus 1, which is, if we distribute that, 10x minus 5. So our perimeter is 10x minus 5. But that's not the whole question. The last part we have is, what if x equals 3? What if x equals 3? So if we replace that with x with 3, so 10 times 3 minus 5. Well, that would be 30, so we should get 25. So there are two parts to our answer here. First, if x is 3, the perimeter is 25. If we don't know what x is, then the perimeter is 10x minus 5. All right, that brings us to the end of these notes. Just remember, don't call me a monster. We're going to be using that quite a bit. Don't call me a monster. All right, there's the end of our notes.